In this video we look at parallelograms, and in the old days, Theorem, Theorem 9 was your parallelogram theorem. Proved that opposite angles and opposite sides in a parallelogram are equal in measure. So these angles are equal. If we call them both 1, these angles will be equal, and we will look at this theorem in this video or the next one. These sides here, these two are equal, and this side here and this side here are equal. And our proof is, our construction is this diagonal line here to create alternate angles. Just to introduce this, let's see our Z from before. We know where our Z alternate angles, we can see, are going to be in this triangle, and we're going to have a common side, and we'll get to the proof quite easily in Theorem 9. So what types of parallelograms have we got? Well, a parallelogram, it's a quadrilateral for which both pairs of opposite sides are parallel. And there are different types of parallelogram, each with their own properties. So, type of quadrilateral, parallelogram, opposite sides are equal, opposite sides are parallel. You can see here, they have put in x's here, opposite sides, opposite angles are equal, and the diagonals also bisect each other. So, this side and this side are going to be the same length, and this side are going to be the same length. For a rhombus, we have 4 equal sides, so it's a square that has been moved either to the right or to the left. So our rhombus in this case is going right. It's 4 equal sides, opposite sides are parallel, opposite angles are equal, and the diagonals bisect each other, but the angle formed in the middle is 90 degrees. That's the difference with a rhombus here. Okay, so we've got 90-degree angles on the bisection. So that's just an introduction to the different types of parallelograms. We also have quadrilaterals, rectangles, and in rectangles opposite sides are equal. See here, opposite sides are parallel, all the angles are 90 in a rectangle, and the diagonals bisect each other. In a square, the sides are equal, sides are parallel, the angles are 90, and the diagonals bisect each other, and again 90-degree angles in the middle. So the rhombus and the square have the same thing going on with the 90-degree angles in the middle. And Theorem 9 here, which will prove a square, rectangle, and rhombus could all be described as being parallelograms, and this theorem holds fit for all of those. And in a parallelogram, opposite sides are equal and opposite angles are equal in measure. So consider this parallelogram ABCD. The opposite sides are equal. AB is equal to DC. Just really straightforward information about parallelograms. The opposite angles are equal. BAD, the angle A, is equal to BCD over here. Give them both a 1, and ABC B is equal to ADC, this one here. And the converse of Theorem 9 also applies. A convex quadrilateral has both diagonals completely contained within the shape. Each interior angle is less than 180. And case 1 ABCD is a quadrilateral, and converse to Theorem 9, for a convex quadrilateral, if opposite angles are equal, then the quadrilateral is a parallelogram. So don't get confused by all the words. When we get to the math behind this, it'll become really easy. In case 2, ABCD is a quadrilateral, converse to Theorem 9, and the second part is, for a convex quadrilateral, if opposite sides are equal, then the quadrilateral is a parallelogram. Theorem 10, the diagonals of a parallelogram bisect each other, which we would see in Theorem 9. And you can read through this yourself. Just down to corollary 1, a diagonal divides a parallelogram in 2 congruent triangles, which is really important. These 2 triangles will be congruent, where they have a common side, they have a common angle here and here, and they also have another common angle here and here, due to your alternate angles. So let's look at Theorem 9. Opposite sides and opposite angles in a parallelogram are equal in measure. So what are we given here in this? We're given a parallelogram ABCD. So I'm just going to draw it. Doesn't matter where you put your letters. ABCD, and we have to prove opposite sides AB is equal to DC, and AD is equal to BC and also the angle DAC, this one here, has to be equal to the angle DCB, and the angle, we go for this one, ADC, has to be equal to this one, the angle ABC. We've mentioned already that we're going to use congruent triangles and look at the bisector here. So my construction here, draw, you can either do AC or DB. I'll do DB, bisector, bisect the parallelogram 2, but I just need to write draw DB and mark angles 1, 2, 3, 4. So let's do that. Draw DB, mark my angles 1, 2, 3, 4. 1, 2, 3, 4. Again, it doesn't matter where they go, it's the maths behind it that's important. So let's have a look at what we can say about these angles. So what can we say? We can say angle 1 is equal to angle 4. We could also say that angle 3 is equal to angle 2, and they're both the same reason. They're both alternate. Same reason. And what can we say about DB? This is a common side. Now we could have stated at the start what we were doing. We're going to compare two triangles. This is a common side to what? To the two triangles. Therefore, triangle, this one up here, ABD, and this one here, triangle BCD, are congruent. How? By angle, side, or SAS, the two sides and the angle the two angles and the side in between. Two angles on the side in between, ASA, the two angles and the side in between. And if these triangles are congruent, therefore the top side, this one, has to be equal to this one. AB has to be equal to DC. This is what we've been asked to prove. Also, we'll have AD is equal to BC. So again, just repeating what you had at the start, AD is equal to BC, and also the angle, this one here will have to be the same as this one. The third angle is the same if the first two are the same. So the angle DAB is equal to the angle BCD. And we just need to say this last angle is equal here. So 1 is equal to 4. Angle 1 equals angle 4. And angle 3 equals angle 2. Therefore, angle 3 plus angle 4 is equal to, it has to be equal to 1 plus 2, which is equal to the angle, what do we call it, ADC. ADC is equal to, just get your letters right, ABC we call it, keep it in the same order, the angle ABC. Therefore, opposite angles and opposite sides are equal in measure. QED.